Guys, so yesterday we spent quite a lot of time talking about triangles and specifically the perpendicular height of a triangle and how sometimes it looks different. Sometimes it's not just one of the sides of the triangle. Sometimes it's on the inside of the triangle. Sometimes you can only draw it on the outside of the triangle. So what I'm referring to is in the note that I posted yesterday, but I drew 3 examples where the perpendicular height is drawn differently. So in this triangle, the perpendicular height is a side of the triangle. In the middle one, it's not actually a side of the triangle because this is not a right angle triangle, but it's still the actual height of the triangle from the base to the highest point. All right, that is the definition of the perpendicular height. All right, and for this triangle, which is an obtuse angle triangle, the perpendicular height, you can't draw it on the inside of the triangle like we could for this one, but it is still the actual height. So the distance between the base and the highest point of the triangle. All right. So for all of these, we can see that all 3 of these triangles would have the same perpendicular height, which is 2 lines on this page, for example. Okay. Even though they look very different, their bases are obviously different, but all 3 of them will actually have the same perpendicular height. All right, so that was quite important for this one, where you had to find the area of this arrow shape. Now, obviously, we don't have a formula for finding the area of an arrow. All right, so we need to break the shape up into shapes that we actually have formulas for. So a triangle and a rectangle. Now, guys, they will always give you enough information to actually figure out the measurements of the various shapes. So if you draw a dotted line there, do we see that this is a triangle and that's a rectangle? Right? Now, in this case, we don't have the lengths of either one of those 2 sides. So we can't choose one of those 2 as the base, right? What would be the use if we don't have those sides? Okay, so what we actually do is we choose this length as the base because we have that length, right? That length is 11. Now, if that is the base, we can turn it on its side like that so that it looks like the base, right? So that this triangle is standing on the base. What is the perpendicular height of the triangle then? From the bottom to, sorry, my arrow should have stopped over there. From the base to the highest point of this triangle, that is the perpendicular height. So that's actually 5 in this case. All right. So that is why for our finding of the area of the triangle, we said half times base, which is 11, times perpendicular height, which is that, right? That distance there, which is 5. Okay, does that make sense? Plus the area of the rectangle, which is very easy. We all know how to find the area of the rectangle or a rectangle. It's length times breadth. Now, in this case, they told us that this whole arrow is 17 centimeters long, right? But that part is not 17 centimeters. Can we agree on that? The actual rectangle is not 17. That is 5, so that must be 12. Okay, so you can see I wrote it in pink there. So the area of this rectangle is going to be 12 times 3. Okay, so you add those together and you get your answer. Are there any questions on that one, guys? All right, exercise 16.3, there we have 1A and C. All right, so I redrew the pictures so that I could show you how I split my first one into shapes. Guys, your shapes could be different from mine, all right? I decided to just split it into 4 rectangles going down like that, but you could have done it differently. It doesn't matter as long as your answer is the same. Okay, yes?
I got 155.4.
Did anyone else get this answer? Did anyone get 165.4? You got this answer as well. Okay, just check. Cameron, did you use the same rectangles?
I did 1 line across the top. Oh, that's why. I did the top, that whole block there as 1. So you can see that it was 4.
Oh, okay. Yeah. All right. So guys, what I did was, remember for the 4 rectangles here, if your working is different, like I said, it's fine. I'm just going to explain how I got my measurements. So for a rectangle, remember it's length times breadth, all right? Just the 2 sides multiplied together. So for that first one, it's quite easy to see. that it's 11.5 times 4. All right. For the second one now, if you look at that pink one there, that side is also 4, but now I need to figure out what these longer sides are equal to. Now the whole length of this big shape is 11.5, and that is 4. So this length has to be 11.5 minus 4, right? So that these two together, if I take whatever this number is plus 4, it should give me that whole side, that 11.5. So that's how I got 7.5 there. All right, because the whole length is 11.5, but now we're taking away 4 centimeters there. Okay, so that's the second one, 4 times 7.5. My third one, the bottom side here, we can see is 6. And guys, if we're just looking at this rectangle there, it has the whole length, right? It's again 11.5, this whole one, that's number 3. Okay, so that one was 6 times 11.5, the whole side there. Here we go. And then this last one on the side was 4 times 6.7. All right, then if you add all of those together, you get that answer. Any questions on that one? All right, for C, you had to actually find the area of the whole rectangle, and then you had to minus the area of this triangle. All right, this was a cutout question. So the whole rectangle is quite easy. It's 12 times 8, right? Length times breadth, 12 times 8. Minus, now we needed to find the area of this triangle. Now, I think I did go through it in yesterday's video. All right, I explained to the other group how to get this length here. If this side is 12, this whole side is also supposed to be 12. Now we're trying to find the length of the base of the triangle, which is like the cut away part, all right, the way that's been taken out. Now, if that is 4 and that is 4, sorry, 3 and 4, I nearly said 4 and 5. If that is 3 and that is 4, then I can figure out what I must still add to that to get 12, right? What is 12 minus 3? 9 minus 4 is then 5. Okay, so these 3 separate lengths must now actually also give me 12, because this is a rectangle, right? So I know that if that's 12, then this one at the bottom must also be 12. Okay, so that is the base of the triangle, yeah? Now we need the perpendicular height. So I did this with yesterday's group as well. You can just draw your perpendicular height there, going from the top of the triangle always to the base. All right, now guys, if this side is 8, then this also has to be 8, right? Because it's a rectangle. Does that make sense? So if that is 8 and this part is 4, then that part, the perpendicular height, will also have to be 4. Okay, so that is what you're minusing. A half base times perpendicular height. That's the formula for the area of a triangle. So a half times 5 times 4, and then you get your answer. And please, you have to remember to do millimeter, whatever the unit was, and to then square it. Okay, that's very important. You lose a mark if your unit is wrong. Any questions on this one? All right, then the last one that you had to do was 3A. So this was an envelope, and I don't know if you guys have seen envelopes like those before. I don't know if they're still being used, but where it's a paper envelope and then there's like a little plastic see-through cutout on the front. All right, so they just wanted the area of the paper. So it will be the area of the big rectangle, the whole envelope, minus the area of the part that's been cut out. Okay, so which is also a rectangle, which is also quite easy to find. And what was nice here is that they gave us all the values that we needed. We didn't have to calculate anything. We just needed to understand that if we're taking away this rectangle here, that's literally what we're going to do. We're going to minus the area of that rectangle. So we take the area of the big rectangle, 22 times 11, and then we minus the area of the small rectangle, which is 5.6 times 9.7. And then we end up with that answer. Yes. So that's why I said you must just do 3A, so that you don't have to do 3B as well. Okay, we're going to still talk about conversions later, but you weren't supposed to do B as well. Okay, any questions on that one, guys? All right, yesterday I didn't discuss circles with the other group. In the past, we used to do like a whole little investigation where you have to like cut stuff out and so on, but yeah, it's not in these notes. So we won't do that. That's fine. So we are just quickly going to write down the formulas for the area of a circle, and then not the perimeter, but the circumference. Okay, that's the word that we use. So you can just write down a new heading, circles, and then you'll write information. If you have a math set here, you can draw a little circle underneath your heading, or you can just freehand it, I suppose, if you want to. It's not the end of the world. Okay. Yeah, that's just going to be quite big, maybe with Prit. Yeah, you can use your Prit and you can draw like around it. I'll just freehand it. It's fine, doesn't matter. If you want? No, it's fine. Well, I'm going to post these notes on Classroom anyway, so you don't really have to. If you can, if you want. Okay, circle, and then I'm just going to draw one quickly. Oh no, where is mine? Oh gosh, I thought I was sorted and I'm actually not. Okay, let's see. It's small. Let's see if I can find one. Okay, I'm going to do a little one using the lid of my water bottle. Let's be inventive here. Okay, we're doing a small one there. That's big enough, actually. Okay, now, however you have drawn your circle, I want you, obviously, if you've used your compass, then there will be like a hole where the center is of the circle. Just draw a little dot there so that we can see exactly where the center is. If you have used a lid or your Prit or some other way, then just kind of guess where the center of the circle will be. It doesn't have to be accurate, okay? So I'm just drawing a dot there. I suppose that's where the center would be, okay? It's fine if it's not accurate. And then I just want you to take, it's literally lying under my book. Did it just appear out of thin air? Wow. Okay, anyway, let's just take a ruler, and now we're going to draw a straight line from that center to the edge of the circle. And it can be anywhere, guys. It can be like directly next to it, it can be underneath it, it can be on the other side. All right, yours doesn't have to be exactly where mine is. Yes. Yes. Yeah. That's exactly what we're doing. Okay, now guys, the edge of a circle, right, is called the circumference, but also the perimeter. So if you were to measure that whole edge, imagine it's like a piece of string that we've turned into a circle. And then if you were to lengthen that piece of string, that would be almost the perimeter of the circle, right? The length that goes all around the circle. So that is also called the circumference, all right? So the circumference is the edge of the circle, but also the length. We kind of say, we want to say perimeter because it's the same concept, but we don't call it the perimeter, okay? So I'll just put in brackets here, perimeter. But when we are working with a circle, we don't actually use that word. Okay, we actually use the term circumference. So if they're asking you to find the circumference of a circle, that's basically finding the length around the circle. Okay, so imagine if you have a circular field and you have to span a fence all around it, all right, then that will be the length of that fence will be the circumference. Now this line that I've drawn from the center of the circle to the circumference of the circle to the edge is called a radius. So we'll just put an R there next to it. Okay, and just on the side, I'm going to write that R is a radius, which is a line from the center to the circumference of a circle. Then I want us to take a different color if you have. All right, and now we're going to draw in a diameter of the circle. I'm sure some of you know what that means. So now you're going to draw a line that goes from one point on the circumference to another point on the circumference, but it has to go through the center. And again, guys, it doesn't matter where yours is. All right, you can draw yours going straight across, going straight down at a different angle. All right, but it has to go from the circumference through the center and then to the circumference again. All right, now this pink line is what we call the diameter.
Yeah, would the diameter always be half of the circle?
It will cut the circle. Always, yeah. Okay, so let's write that. D is the diameter. So that is a line from one point. I'm just going to use PT, short for point, on the circumference through the center to another point on the circumference. And I'm just going to abbreviate that there. Okay, I think we've written the word circumference more than enough times now. Okay, something that's interesting about the diameter and the radius is that the radius, the actual length of the radius, will always be half the length of the diameter. All right? Do we agree that if I look at my pink line, if I just look at that part of it, that is also a radius? Right? That's also from the center to the circumference. So this part of the diameter is also a radius. And guys, all radii, that's plural for radius, radii, R-A-D-I-I, all radii always have the same length. All right, so this blue radius here will have exactly the same length as the pink radius there. But then if I cover this one up, isn't that part also a radius? Yeah. It's also going from the center to a point on the circumference, right? So this is also a radius. So the diameter is actually made up of two radii that have been joined. All right. So the diameter is always 2 times the radius. The actual length of the diameter is always 2 times the radius. Or you can say the radius is always half the length of the diameter. You have a question? Okay. Just going to write that quickly here underneath. So the diameter is always 2 times the radius, and the radius is always half the diameter. Okay, that will always be true. So if they've told you that the radius, for example, is 3, then you need to know that the diameter will be 6, right? Double the radius. Or if they've told you that the diameter is 6, you need to understand that the radius will then be half of that, 3. Okay. Now we actually get to the formulas for area and circumference. Yes.
We're trying to find the length of the picture.
Mm-hmm.
Then could you say that it is squared?
This one, the circumference here. it's not going to be the radius squared. I'll show you now what the formula is. Okay. So for area, let's do area first. Area is pi radius squared. Now you might have worked with the number pi in primary school. You've probably seen some meetings with the number pi on it. Pi is actually a number, right? It is an infinite number. It never ends. Okay, so it is just one of those funny numbers that it's 3,14159 or something. All right, but luckily for us, the calculator has a pi button on it. So if you have this calculator, any Casio, it doesn't have to be the silver one, it can be the black one or the pink or the blue, whatever. And I think other calculators also have that button. I'm just not sure where it would be. On the Casio, if you look there at the bottom, it says times 10 to the x, right? Above that button, there is a pi symbol. Let's see if you can see that. On mine, it's in like yellow printed there. So if I want to use pi in my calculation, I would say shift, and then I would press that button, and then the calculator uses the actual value for pi. All right, in the textbook, they sometimes say use 3,142 as your pi value. We don't do that. Okay, you want the actual answers? So we're going to work with the actual pi button and the actual value for it. You have a question? Okay. All right, is that fine, guys? Then the circumference, which we just use a C for. All right, so for the formula, circumference. Now there are two formulas that we can use. It's either going to be 2 pi radius. Again, we would use the pi button. So that means 2 times pi times the radius. Just hold on. Or, guys, what is 2 times the radius equal to? 2 times the radius is equal to the diameter. So we can actually say, instead of 2 and radius multiplied by pi, we can say pi just multiplied by the diameter. That will give us the same answer.
Why is it we use the circles?
So that was the whole investigation thing that we used to do in the past, and I'm not sure where that's saved. So I'll see if I can find it. It's a bit difficult to just like say it in a sentence.
And
Okay,
this
but-
investigation thing we're going to do is it's going to be the round. This sort of stuff.
Stuff that we're doing now. Okay, when I say there's an investigation on this, I mean there's like a little activity that we used to do in class. Yeah.
Sorry, off topic, but the investigation is this Thursday, right?
Yes.
Like, and you said we can't study for it.
Yes. Yes. Okay, so those are the two formulas, guys. So if they're asking you for the area, you're going to take pi on your calculator times by whatever the radius squared. All right. If they're asking you for the circumference, it's 2 times pi, that button on the calculator, times by the radius. Or if they've given you the diameter, you can say pi, that button, times by what the diameter is. Okay. I am going to give you some work on circles that is in your book. So it is exercise 16.2, which is on page 190. And I want you to do numbers 1 to 3, please. Okay, all 3 of those questions are on circles, so you're going to use these 2 formulas to answer those questions. Okay, you're practicing those. And this is for tomorrow, guys. So I'm going to mark these questions with the other group. So you need to mark your homework at home. But please do it before you watch the video. Okay, otherwise there's no use doing it. All right, there are only 4 minutes left. Oh, actually, no, we're not marking it tomorrow. The other class is doing, well, the other group is doing the investigation tomorrow. So this will be for Friday. So I'll mark this work in the other group session on Friday. Okay. Okay, you can pack up. There are only 4 minutes left. So pack up and sit quietly for 2 minutes.